Thanks, Cameron. Again, I'd like to welcome everyone to our SACU webinar today, DNA 101 for Law Enforcement Agencies. Today, our presenter will be Amy J. Amy is with MindGen LLC. She has spent her career working in the private forensic industry supporting efforts worldwide to prevent and eliminate DNA backlogs, refining operational logistics, and providing quality and technical system support. She also has a bachelor's in biology from Michigan State University and a master's of forensic science from the George Washington University. And she currently works as the principal consultant for MindGen LLC. At this time, I'd like to welcome Amy and turn things over to her.
Thank you, Amanda. Well, hello, everyone. Today, I'm going to be talking about forensic DNA testing and reporting. This was developed for those with a beginner's mindset. So if you are new to understanding forensic DNA, this is going to cover the basics, and I'm going to try to make it as painless as possible for you. I do want to point out in the bottom left-hand corner, there is a file share. Here you can find a document that's going to cover some of the material in today's presentation. And this is in a brief format that can be easily referenced and also distributed. Overall, the goal of this presentation is to make sure that as law enforcement, there is enough basic understanding of the science in order to know what DNA testing can and can't do to help with the investigation. This will help put you in a better position to ask questions and to understand basic language used in a forensic DNA report. Given that, I will be covering very basics of molecular biology and short tandem repeat testing, the most common type of testing used in criminal casework. I'll discuss sources of DNA and what can affect DNA recovery in a sexual assault kit. We'll go over common laboratory workflows for sexual assault kits, and we'll cover reporting languages and decisions to include going through a mock case. So to start, DNA is found within the cells of our body. Nuclear DNA, what is most commonly tested, is located within the nucleus of, or the brain of the cell. Maternally inherited DNA, or is located in the mitochondria, which is the energy powerhouse. I just want to point out these differences, as mitochondrial DNA testing is a tool that can be used, and I'll talk about that briefly on the next slide, but the majority of criminal casework takes place in the nuclear DNA, which is packed tightly into chromosomes, where the testing is occurring. There are 22 pairs of human chromosomes and one pair that is commonly used as sex determination, or the XY chromosomes. The pairs exist because half of a person's DNA comes from their mother and half of their DNA comes from their father. The STR testing takes place throughout the chromosomes. There is also YSTR testing that focuses just on testing the Y chromosome. And as mentioned in the previous slide, mitochondrial DNA is found within the mitochondria of the cell. Although not as discriminating as STR testing, mitochondrial testing has benefits because there are multiple copies of mitoDNA per mitochondria and many mitochondria per cell. Therefore, it is useful for compromised samples that can be difficult to obtain STR data, things such as bones, teeth, and hair shafts. STRs are really just simple, short segments of DNA that are in tandem and repeat over and over again. It is the difference in the number of repeats at each location tested that creates the differences between humans and which cumulatively create a DNA profile. In this example, D8S1179 is the name of a location tested, and the DNA profile for this location is an 810 because one chromosome has 8 repeats and the other has 10 for this location. STRs are a preferred method for testing since currently more than 20 locations can be tested simultaneously. The data can be obtained from very small amounts of biological fluid, and STRs are highly variable between humans. So if multiple locations are tested, we can start to distinguish between people. This is a type of technology that is used and databased all over the world. This information can be easily shared throughout jurisdictions in the United States and even worldwide. Because of this technology's flexibility and durability, it's used in paternity testing, human identification, and criminal forensics. Scientifically, the difference in the number of repeats is often referred to as an allele, if you ever hear that term, and the locations that are tested are referred to as loci. I'm going to try to prevent using those words during this presentation, but those are common scientific representations of this as well. Sources of biological material are many. DNA is highly likely to be obtained from sources of biological fluid, such as blood, saliva, tissue, semen, and sperm cells. DNA from skin cells can be successful, especially on items someone has been wearing. It can become less reliable on items that have just been touched, but still possible. Skeletal remains and teeth can also be suitable for DNA testing. Hair roots are also a good source, but there is no nuclear DNA in the hair shaft, so that is only suitable for mitochondrial testing. Urine and feces can be known to create human DNA profiles, but these are rarer to test since there's not always a lot of starting material, such as a lot of DNA present in those samples, and since there is generally a lot of bacteria, that can inhibit the sample from producing a human DNA profile. Given the sources, the items that can be submitted for DNA testing vary widely. In sexual assault cases, depending on the case scenario, it is common to start with testing any intimate swabs, such as vaginal swabs, anal swabs, oral swabs, or other body swabs. Successful testing can also be obtained from underwear, bedding, condoms, and wrappers. As mentioned previously, sources of biological fluid, blood, semen, and saliva are among some of the best sources to collect for DNA testing, as they tend to produce robust and high-quality profiles. Items left behind at a crime scene that may have been worn by a possible perpetrator can also be good sources, such as hats, shirts, pants, sneakers, and gloves. Generally, these tend to be common items that get left behind, so make sure that they're not overlooked. Cigarette butts, bottles, straws, and cups that have been used may also contain saliva, which can be tested for DNA. In human identification, missing person cases, any skeletal remains, teeth, or even hair roots are commonly submitted. In some jurisdictions, swabs collected from touch items have had success, but recovery of DNA can be variable. That would be those from firearms, swabs from surfaces of windows, steering wheels and doors, and other weapon handles. There are many factors that can influence the recovery of DNA in a sexual assault kit. So condom use during assault can prevent recovery of DNA from internal swabs, but DNA may be able to be recovered from body swabs or the inside or outside of the condom if available for collection. If ejaculation even took place, or the volume of ejaculate can also be a factor, along with sperm count, and if the male has been vasectomized or is medically azoospermic, which by both of those counts would just mean that there's no sperm present in the seminal fluid. In addition, certain hygienic conditions, such as bathing or showering following assault, can reduce chances of DNA recovery from the body. And bowel movements and menstruation following assault can also cause DNA reduction. The time between assault and collection can also be important. The closer the collection occurs to the time of assault, the greater the chances of collecting remaining DNA. However, it's possible that DNA collected within 72 hours can be a reasonable sample, and even farther out timelines can be useful for Y chromosome-specific testing. In the National Sexual Assault Kit Initiative that's taking place, some kits have also been stored for a really long time. And if there's been fluctuating changes in temperature and humidity of the storage, that can also affect DNA recovery. So DNA generally takes place in sequential steps. Some jurisdictions will start by screening items for biological fluid or possible DNA, then only if detected, move forward with additional steps. In this flow, possible DNA is then removed from substrates such as a swab or cutting during the extraction stage. The amount of human DNA recovered is determined during quantification, and based on that, the STR regions of choice, currently commonly at least 20 locations, are targeted for amplification, where the STR regions are copied. Computer software then helps characterize the STR regions and generates a DNA profile. This is occurring during the analysis stage. Once a case file has been completed, 100% of documentation will undergo a technical and administrative review. Then the results, comparisons, conclusions, and if applicable, statistics are communicated in a final forensic case report. If an item is being screened for possible biological fluids, it is common to test for possible semen or spermatozoa in sexual assault kits. This may be performed by simple color changing tests which indicate possible presence of semen through changes in enzymatic levels, or a visual microscopic examination may be performed to view the presence of sperm heads under a microscope. There are other types of biological fluid tests. This is just covering a couple of them so you can be familiar with what's available. It's important to understand that presumptive exams are only indicative of possible semen and does not mean that semen is definitely located on the item. So common wording that you may see in a report would be that the vaginal swab tested presumptive positive for the presence of semen, or presumptive testing for the presence of semen on the vaginal swab was negative, or semen was indicated on the item vaginal swab. So just note, if you see the words presumptive or indicated, these are not conclusive statements. These are just helping the examiner screen the evidence to potentially identify where DNA may be present in order to proceed with the additional steps in the DNA workflow. Confirmatory tests are going to often usually contain the word confirmed in the result statement, such as semen was confirmed on the vaginal swab or spermatozoa were confirmed on the vaginal swab. Or in a negative case, you may see something like presumptive test for the presence of semen was inconclusive for the vaginal swab and confirmatory testing was negative. So confirmatory will mean that according to the lab's current standard operating procedures, the test or test performed confirm the presence of seminal fluid or spermatozoa. When you see the word spermatozoa, that just refers to the detection of an actual sperm head or a sperm head with tail. Things like semen or seminal fluid may just indicate enzymatic levels or different ways of detecting if those fluids could be present in the sample. However, a shift has started to occur throughout the United States to include screening for male DNA as a replacement for more traditional biological fluid screening techniques just discussed. This method has been referred to as many names. So you may have heard direct-to-DNA testing, Y screening, Y chromosome screening, or male DNA screening. Just note this all refers to the same thing. So instead of individually screening cases for biological fluids, which can be quite time-consuming, a shift occurs in case assessment to the DNA quantification step. This helps ensure that the best sample is used for DNA testing and that the DNA is actually tested. So we're not just looking for a possible byproduct of a fluid that may indicate that there's DNA there. screening at quantification has been shown to be reasonably better at detecting male DNA, and it can reduce the turnaround time for kit testing. DNA extraction in a sexual assault kit has been devised to help separate possible sperm cells from other cells located in the sample, such as common epithelial cells. Sperm heads are very hardy and actually tough to break open. So using this knowledge, the epithelial cells are broken up to remove the DNA into its own fraction, often known as an EF. Note that laboratories may use slightly different names, but one is generally going to be for the epithelial fraction, and one will represent a possible sperm fraction. So once the epithelial fraction has been put off into its own sample, any possible sperm cells that remain will be exposed to harsher chemicals that can then be used to release the DNA from the sperm cells into a SF, or sperm fraction. Therefore, every sample submitted in a sexual assault kit that may have a reasonable expectation to include semen will usually be extracted in this manner, known as a differential extraction, such that two fractions, the EF and SF, are created from one original sample. The SF typically contains male DNA from the sperm cells, and the EF will contain the female DNA. This is in instances of a male and female assault. And this is also under ideal conditions. Due to variables discussed on the recovery of sperm and possible quality, degradation, and even extraction efficiency, there can be carryover of female DNA into the sperm fraction and male DNA into the epithelial fraction. If a laboratory is using a workflow which includes male DNA screening, it typically is going to take two different approaches. One is to screen before the differential extraction. So in this type of workflow, a very small cutting is taken from the sample, and a very fast and crude DNA extraction is performed to break open cells and release DNA, and then the sample will proceed to quantification in order to determine if there is enough human or male DNA to proceed with further testing. If there is, in those cases of the workflow, the laboratory will go back, take another cutting, and perform a differential extraction to proceed through the whole workflow. Other laboratories have taken an approach that instead of screening up front and then going back to re-extract, that they'll make DNA screening part of the workflow. So in these cases, usually a larger cutting is taken for DNA testing, a differential extraction is performed, and then the sample will proceed to quantification with human and male DNA detection. The quantification step, which estimates the amount of human DNA and male DNA, is then performed to help aid in process decision-making. So from the quantification, labs can make a determination if there is enough DNA to proceed with downstream processing. They can evaluate mixture ratios to determine if enough male DNA exists to proceed with STR or YSTR testing. And a laboratory can evaluate the quality of the DNA extraction by determining the presence of possible inhibitors. So this becomes an important processing step regardless of where the screening is taking place. If a laboratory is using male DNA screening in lieu of biological screening, it's generally going to be noted in the report. So based on quantification results, you're going to see how they're reported, and the quantification results should help indicate if the sample was processed further or did not proceed to STR testing. So this is some example wording that you may see that would be common. You may read that male DNA was present on the vaginal swab. This sample was processed further for STR testing. So in this case, you would expect to see an STR result, whatever that profile would be. You may see a statement which reads, male DNA was not present on the vaginal swab. This sample did not proceed with further testing. that would give an indication that if there was male DNA present on the vaginal swab, it was below the limit of detection of the quantification assay that was being used and did not show up that it would be able to produce a DNA profile, so the laboratory stopped processing at that stage. You may also read that male DNA was inconclusive on a vaginal swab. Inconclusive depending on the results of other samples in the case. Sometimes inconclusive samples will be taken forward and sometimes they're not. So it should be indicated if they were and why or why not. And just note that these inconclusive results can sometimes be good candidates for YSTR testing. So it could be worth talking to the laboratory about that possibility if there are no other potential prospects based on STR results. And another common reporting statement is that male DNA was present on the vaginal swab, but due to high levels of total human DNA, the sample was not processed further for STR testing. What this is just indicating is the ratio of human to male DNA is so skewed that there's likely a lot of female DNA in the sample. So if it were to proceed to STR testing, you likely would only produce a female profile or maybe just very minor peaks from another contributor. Depending on how much male DNA is present, these also can be good candidates for YSTR testing. So based on the results of screening, the most common next step for suitable samples is to proceed with STR testing as it's most discriminating. As mentioned, screening can also indicate if YSTRs could be viable. Although YSTRs are not as discriminating as the Y chromosome is passed down from the paternal lineage, but it can help target male DNA and can be a great option if there are possible indicated perpetrators and no STR profile was detected. Currently in the U.S., there are a few labs that are using a combined STR and YSTR approach, noting that together, both of these technologies can be valuable in helping to resolve mixtures and provide clarity for the overall case. So if you work in one of these places, you may see YSTR and STR results reported in the same case file. The name of the commercial STR kit or chemistry used to detect the STR profile should be noted in the report. And I'm just covering this so when you see these possible references, you may recall what they mean. These are listed here, the top commercial kits in the U.S. that target at least 20 loci. There was a switch just at the beginning of this year in 2017 that the U.S. database, CODIS, is switching to require at least 20 loci. So unless the laboratory has asked for an extension, they have switched to one of these kits. And so you'll be getting a lot more data back with your case reports. So these new kits have been developed in recent years and mostly implemented probably within the last 6 months. And if you haven't seen them yet, I would expect within the next 6 months you'll start seeing reports back with some of these commercial kits. The ones that have additional loci, so at least 20, have also worked on their chemistry to help improve DNA testing. So they're kind of touted as being better than what's been used in the past, but really they're new, so we'll kind of see with experience with the kind of data that's being produced. But some of the things that they offer as promising is that they're more discriminating. The power of discrimination should be higher because there are more locations being tested. There may be improved degraded sample recovery due to the smaller STR locations that are included in the chemistry. There may be improved inhibited sample recovery due to enhanced chemistry and also increased sensitivity, which may or may not be a good thing. Again, that will be something that will be noted in time with experience with these kits is obtained. When examiners are seeing the data from the computer-generated DNA profile, they are really looking at a series of peaks which represent the variables detected at each DNA location. So as mentioned, as a switch at this year, there are more locations being tested in the DNA to include a minimum of 20. And listed in the table here are the 20 core CODIS loci that are now a requirement for upload into the national database. So when examiners analyze the DNA profile, they should be examining the evidence of any unknown samples first, as this produces a possibility of bias that could be introduced by analyzing the known samples with the unknown samples. From the data, the examiner can determine profile quality, the number of contributors, and may even deduce a profile into major, minor, or foreign components. And this will help further in the comparison stages. Generally, results will be summarized in a table format, which may be included as part of the report or will be included in the case file. The analyst will conclude if the resulting profile is single source or a mixture, such that single source profile represents DNA from one contributor and is generally recognized by the presence of no more than 2 alleles at each location tested. And generally, these are going to have overall good quality, but not always. In a mixture profile, DNA will be from more than one contributor, and this is generally recognized by the presence of 3 or more alleles at each location tested, or by looking at those peaks, they'll vary in height, which is referred to as peak-height imbalance. And mixtures are generally reported as 2 people, at least 2 people, or 3 or more. And the laboratories will have validations and procedures in place to help them make these determinations. So there's many common reasons that a mixture might be present in a sample. It could be any combination of a victim, perpetrator, or consensual partner. It may indicate multiple perpetrators. There may be poor differential extraction efficiency, such that I mentioned carryover of the EF into the SF or the SF into the EF. And less common, but still an occurrence, would be contamination, either from the crime scene, police, collection staff, or laboratory staff. And this is why it's important when possible to have DNA collections from staff that have been in contact with the submitted samples and can be verified that they're not in the resulting profile. Laboratories that have staff databases as QC measures quality control will run their case profiles against their staff profiles as a means to ensure that no contamination occurred. Results might also be indicated as partial profile or no results. Such that is, in a partial profile, information is missing from some or most of the locations typed. This can be indicated of a sample that needs additional testing, is degraded, is inhibited, or is of limited quantity. And no results just means that no DNA was detected at any of the locations that were typed. After the unknown samples have been characterized and analyzed, the results of any submitted, known, or reference material will be analyzed next. Known samples will be processed at a separate time and space from evidence samples. The known samples should be single source, so if there is indication of a mixture, it generally means there was some kind of issue either with collection or testing. The victim's profile is important to test, especially in these sexual assault kits, because it can be important to establish chain of custody and also help deduce out a foreign or male component. And elimination samples, such as consensual partners, should also be submitted for comparison, such that if a foreign profile is developed and would like to be uploaded into CODIS to help identify a possible perpetrator, just want to make sure that the DNA profile doesn't possibly belong to a consensual partner. So the collection of elimination samples can be critical for that process. And then generally, just like the evidence samples, you're going to see a summary of the results. in what is often referred to as an allele table or a summary table. There are report features that will be common for every forensic lab that is accredited in the United States. So if you have it handy, you could pull an example report from your jurisdiction or come back to this later, and you can look for these elements. So every report should include a title, and this is simply just usually referred to as like a forensic case report. You'll see the name and address of the lab reporting the work. There'll be a case identifier, such as a case number or name. There'll be the name and address of the client who is in receipt of the report. There will be a description of evidence that was submitted or examined, the dates the items were received and or tested, a description of the technology. So you should note in the report there'll be indications if biological fluid screening occurred, male DNA screening, STR, YSTR, or mitochondrial DNA testing. The locus or amplification system needs to be present. So you may just see those commercial kit names mentioned in the report, or some labs are going to type out the name of every location that was tested. So you'll see a list of loci, essentially. There needs to be a result in conclusion statements, if applicable, and if needed, also quantitative or qualitative interpretation statements. There will be a date that the report is issued, a statement about the disposition of evidence, such as where the evidence is going to be stored or returned after issuing of the report, and there will be a signature and title of a person taking responsibility for the content of the report. Those are things that are going to be common in all reports. Why I've provided so far variations in report wording is this is something that has not been standardized throughout the United States. So while we've discussed certain words and statements to look for, your laboratory may have certain variations on how they prefer to report samples. So let's talk further about some report features and comparative keywords. So when known or reference materials are available, they will be compared to the unknown or evidence samples. Possible conclusions are typically formulated into 3 buckets. You'll either have an inclusion, an exclusion, or it'll be inconclusive. So an inclusion, sometimes referred to as cannot be excluded, or a match, will refer to the possibility that a known sample could have contributed to the DNA profile obtained from the evidence sample. Whereas an exclusion, also known as cannot be included or does not match, refers to a known sample that could not have contributed to the DNA profile obtained from the evidence sample. Inconclusive or uncertain means that the examiner cannot draw an absolute conclusion of inclusion or exclusion regarding the known sample contributing to the DNA profile obtained from the evidence sample. Sometimes the examiner will even make this statement after looking at the evidence, just noting that it's not suitable for comparison. Anytime there is an inconclusive or uncertain result, the explanation of why will be in the report, or I should say should be. Possible reasons will be that the evidence data is of poor quality, that it's uninterpretable, or that it's unsuitable for comparison. Okay, let's try to apply some of this information to a possible mock case. And we'll just have a brief scenario and then go through the steps of what's going to occur in a laboratory to report this case. So here we have a single vaginal swab from a sexual assault collection was submitted to the crime laboratory for rapid DNA processing. And by here I just mean there is an ideal turnaround time of 15 days. And the victim and possible suspect knowns were also submitted for comparison if applicable. So what's going to happen in the laboratory is the examiner is going to look at the unknown evidence sample, the vaginal swab, first. Typically, they will cut up to half of the sample that's submitted, and in a laboratory workflow that's performing male DNA screening, let's say in this case next, they perform the full differential extraction. So from the vaginal swab, there'll be a vaginal swab epithelial fraction and a vaginal swab sperm fraction. Both of those fractions will be quantified to determine the total amount of human DNA and male DNA present in each sample. And then based on that, indicating that there's DNA present, both of those fractions are going to be amplified with a minimum of 20 STR loci. The results of the vaginal swab will be summarized into a table. So again, this is what I refer to as a summary table or an allele table. And what you see here are, in the left column, loci names. Those are just the scientific names given to the different locations that were tested in the DNA. You can see the word amylogenin, and that's referring to the testing that occurs on the sex-determining markers. So commonly, if you see an XX, that means a female profile has been identified. And if you see an XY, that means a male is indicated in the sample. Next, you'll see the results of both fractions. So you can see where we had one vaginal swab, where there's two DNA results, one from the sperm fraction and one from the epithelial fraction. So what can we draw from this? From the sperm fraction, it appears to be a single source profile. So this is indicated by the presence of no more than 2 different alleles at each location tested, whereas the epithelial fraction appears to be a mixture. And this is indicated by the presence of 3 to 4 alleles at each location tested. Due to this, the data analysis may even indicate that this is a mixture of 2 people. If applicable, at this point, when the victim profile has been determined, you could compare the victim to the epithelial fraction and determine if they're present, and then deduce out a foreign component. Sometimes this is useful if there isn't a profile in the sperm fraction or if it's really weak, to help get more data from the sample. So the reporting statements that go along with these may be, for the sperm fraction, that a DNA profile was obtained from the sperm fraction of the vaginal swab, or that the DNA profile obtained from the sperm fraction of the vaginal swab is consistent with a single contributor. So those are pretty common result statements for a single source profile. The epithelial fraction result statement may start as the DNA profile obtained from the epithelial fraction of the vaginal swab is consistent with a mixture of 2 individuals, or a mixture DNA profile of 2 individuals was obtained from the epithelial fraction of the vaginal swab. So again, there's just different variations that basically mean the same thing. So once the laboratory has kind of gone through that process and established how they're going to interpret the evidence samples, meanwhile, there's going to be another flow going on. When there's viable DNA from the evidence samples, if there are any knowns or reference materials submitted, they're going to be tested on their own track. Generally, less of these samples can be taken up front because they should be high-quality profiles if they were taken directly from an individual. So an extraction will be performed just to remove the cells from the substrate, such as a swab. Break open the cells, release the DNA. In the same manner, the victim and suspect standards will be quantified to determine how much DNA is present in each sample. And that numerical value is going to help determine the volume to amplify, the concentration to amplify. And we'll be using the exact same 20 loci at minimum that we used in the vaginal swab. And then this can just help with comparisons that everything is consistent. We know our reference material results will often be added to the summary table. And while this is a good visual, the examiner will always be using the peak data when making comparisons. So it's important to not overgeneralize the results table, as it can be difficult sometimes to accurately display the results in the table, especially in instances of mixtures, partial profiles, degradation, inhibition, and possible dropout of information. Sometimes these result tables have a big key at the bottom, and there'll be parentheses and dashes and stars and all sorts of things to try to help indicate the quality of the profile. But it's really important to look at the actual data when drawing result statements and making comparisons. But for simplicity of this presentation, we're just going to see what we can tell from looking at the results table about comparing the reference materials to the evidence. So now you can see in this table, you have the loci names listed first, then a DNA profile associated with a suspect sample, a DNA profile associated with a victim sample, the DNA profile from the vaginal swab sperm fraction, and a DNA profile from the vaginal swab epithelial fraction. So you can go line by line and compare the suspect and victim sample to the profiles obtained from the sperm fraction and epithelial fraction. So if we start with the first location, D3S1358, you'll see the suspect sample is a 1718. The vaginal swab sperm fraction is also a 1718, and the vaginal swab epithelial fraction contains a 1718. As we move down to the next location, D5S818, the suspect sample is a 1212, which is also present in the sperm fraction and epithelial fraction. So as we begin to go loci by loci, comparing between the profiles, you will start to pick up trends on whether an individual is included or excluded, or possibly included or excluded to a sample. So what we can see here, if you take the time to kind of look line by line, is that the suspect sample appears to be included in the sperm fraction and the epithelial fraction, and that the victim sample could be excluded from the sperm fraction, but also included into the epithelial fraction. So what might these comparative statements look like? So for the sperm fraction, example wording could be, a DNA profile consistent with the suspect was obtained from the sperm fraction of the vaginal swab, or the DNA profile obtained from the sperm fraction of the vaginal swab is consistent with the suspect. Example wording for the epithelial fraction may state, the DNA profile obtained from the epithelial fraction of the vaginal swab is consistent with a mixture of two individuals. The victim and suspect cannot be excluded as possible contributors to the mixture. Or, a mixture DNA profile of two individuals was obtained from the epithelial fraction of the vaginal swab. The victim and suspect cannot be excluded as possible contributors to the mixture. So again, just slightly variations of themes that mean the same thing. When there is any indication of an inclusion, a quantitative statement shall be used to address the weight of the possible inclusion scenario. A rarity statement is based on the alleles present in the profile, the population allele frequencies used, and genetic formulas that account for population substructure and relatedness. Frequency estimates will be indicated on the report by a numerical value in association with the inclusion. Generally, there will be a variety of population groups that are common in the United States or common to the jurisdiction that you're located in, such that you may see numbers for Caucasian population, Hispanic, or African American. And a single source sample is commonly expressed that the probability of randomly selecting an unrelated individual with this DNA profile is, and it'll be 1 in some number. And if there is a single source match, you're often going to see numbers that are really high, such as 1 in quadrillion, 1 in quintillion, much larger than the size of the world population. And this is just indicating that this is a very rare profile. Now, a mixture may be reported as the estimate of the proportion of individuals in the general population that would be included as possible donors to the mixture is, and then here there'll also be the number, 1 in 1,000, 1 in 100, 1 in a million for different population groups. Generally, mixtures are going to be not as rare of a number as a single source sample because you have more than one person contributing. But they can still help provide keys or clues into the investigation as to what's going on. There are different manual and software applications that help the examiner provide frequency estimates and even help with comparative statements, especially for mixture samples. So you may even be working in a jurisdiction that uses software that will specifically be helping to examine mixture profiles and determine an appropriate frequency estimate to provide. So it's important to note that the lack or presence of DNA should always be examined within the totality of all the evidence in the investigation. Just know that the DNA does not convey guilt or innocence, and the statistic does not express if the person did or did not commit the crime. Also, the age of the stain and the age of the donor cannot currently be determined from DNA. However, these are active areas of research. So just provided a lot of introductory material. Considering we covered the basics of molecular biology, STR testing, sources of biological fluids, common items submitted for DNA testing, what can affect recovery of DNA in a sexual assault, common DNA laboratory workflows, and common reporting language. So if you have any questions, please consider typing them in the chat box, and we can help answer them now. Feel free to review the material in the brief. You can help ask questions later using the SACI discussion board if that's something you have access to, or reach out to your SACI liaison, especially if now, given this material, you go back to your reports and you now maybe have questions about how certain things are reporting, just so you can get a better understanding of how to use the DNA report in your investigation.
Thank you, Amy. It looks like we have some questions coming in already. So Mary says, what is the most up-to-date national standard for timeline of collection? How far out are facilities collecting, 72 hours or 5 days, depending on the type of contact?
What I've seen is there's still a lot of variability between jurisdiction on what the recommendation is. I think as more research is being performed on these kits, especially as a result of the National Sexual Assault Kit Initiative, there'll be more profound impact on these types of policies. And it's going to especially be important to follow the technology that can be applied as well. What we are seeing is that maybe even 10 years ago, 48 to 72 hours was the norm. And now jurisdictions are starting to increase that collection time frame because the technology is becoming more sensitive and because of the availability of YSTR collection which in certain research studies has been able to obtain profiles 6 to 9 days out of assault.
Great. Thank you for that, Amy. It looks like we have more folks typing. If you have questions, please feel free to go ahead and submit those. While we're waiting, oh, here we go. We have a question from Morgan. What are your options with no comparative DNA swabs?
So when you say no comparative, does that mean you don't have any references to compare to? Sorry, I'm asking a question back to your question. No suspect DNA at type of SAC. So generally the best option is to try to obtain an STR profile. The STR profiles are what our national DNA database is run on. And so your jurisdiction may have multiple levels. At the state level, they may be able to do something with a limited amount of information. And then once they would get uploaded to the national level, there's more stringency on the types of profiles that can get entered into the database. Really, through these initiatives, we're trying to create CODIS-eligible profiles so that they can be searched within states and within the United States. So that is usually the option that laboratories are going for. Now, in certain places up front, they're performing YSTR testing on some of these cases as well. Sometimes while that isn't a favorable approach is because YSTRs currently, there's no database to search against. So when you don't have a suspect at the time that the SAC's collected or even later on in the investigation, then there's nothing to compare that YSTR profile to. But if you get a lead later on, then you have that data already available.
Great. Thank you, Amy. We have a question from James. Has law enforcement expressed concern about the direct-to-DNA testing not initially providing whether the DNA came from sperm or not?
In places where they've moved towards a direct-to-DNA testing approach, this is something that's definitely worth talking about in your working groups. Some roundabouts that have been used is the direct-to-DNA testing is used to help screen the cases and kind of get through this kind of backlog. And really where the sperm identification becomes more important is if there is an indictment and if the case is going to go in front of a judge or jury. So at that stage, you can go back to the sample and test for sperm if that's necessary or applicable. There are ways to explain the presence of DNA without needing to test for sperm or semen, but again, this is a discussion to have with the prosecutor's office as well as the lab and law enforcement to find the best route for you. There's also the possibility that during testing, a slide can be created from the DNA extract, and it can be preserved. So that can also be helpful in later on going back and determining if DNA is there. And I see that you've indicated that sometimes sperm identification can be needed during the initial investigation. So again, that could be something in your jurisdiction that you still want to have that sperm identification available to you, but it may not need to happen during the initial screen. It's something that could be part of the test, such as checking for sperm on the back end.
Thank you for that, Amy. It looks like we have some folks still typing. We have plenty of time if people would like to submit questions. Mary asked, does that 6 to 9 day time frame as a guide include vaginal swabs for sperm, etc. only, or can I use that for skin swabs, perianal, perilabial, on my pediatric patients as well?
The research so far has been on internal swabs, so more like a cervical type swab at that 6 to 9 day time frame.
Thank you for that, Amy. We have plenty of time if folks would like to continue to type in questions while we wait and see if folks have any additional questions. There is the file that Amy pointed out below in the bottom left-hand corner. Please feel free to go ahead and download that, and when we send out the archive of this event, there will be a link to that on the SACU website as well. And then Mary asked, can I ask what you might receive for skin swabs only? Recommend.
Yeah, let me, what I want to do is I'm going to pull some of the research, especially on skin swabs. I know I've read a study recently that even after showering, there was still the ability to collect DNA from certain points where saliva had been placed on a person. But generally, as a victim, performs hygiene functions, washes themselves, as the time exceeds even a day or two, then the chances of getting DNA from those types of skin swabs can dramatically decrease.
Mary, perfect. Thank you. I heard that as well, and we are currently trying to collect sometimes after some showers and baths. James asked, how does the lab personnel determine which swabs from the sexual assault kit to examine for DNA?
So in referring to kind of approach that's being commonly used in this National Sexual Assault Kit collection, and I don't want to say this is happening in every lab, but a lot of the contraction agreements that are taking place is that the 3 most probative swabs are being tested. This is generally determined by reading the medical report or proceeding with items that are the chance of getting a DNA profile will be more probative, such as an internal swab versus an external swab.
Great, thank you. It looks like I skipped over a question from Mary. She's looking for that info and wants to know if she can expect it in an email.
Oh, sorry. Yeah, Mary, I will email you the information, and for other people who are on the call who might be interested, I'm going to also post the research in the SACU discussion forum so that everybody can have access to it.
That'd be great. Thank you, Amy. We also have an additional question from Morgan. We have seen a rise in reported male-on-male sexual assaults. Would any of this testing be more difficult since you would have the presence of Y DNA, or is there different testing with these cases?
So generally on male-on-male assaults, they're going to proceed to DNA testing no matter what. So the male screening isn't really going to be used because you're going to expect to see male DNA there. So they're just going to proceed straight to DNA testing. YSCR testing sometimes can be valuable in these cases if to help distinguish mixtures. but generally they're going to proceed straight to STRs, and we'll kind of see what's developed from there, whether it is the male victim profile or whether there is indication of foreign male DNA.
Mary follows up on that. What about father on son, uncle on nephew? Same answer as
Yeah, I mean, laboratory personnel are generally, when there's male and male, are going to be testing more samples because the screening kind of becomes insignificant at that point. And again, we'll also be using the medical report, and sometimes the medical report can give an accurate recollection of the crime, and other times it doesn't really help. Either the person doesn't remember what happened in those instances. There may be more screening that occurs and more testing that occurs in order to obtain a foreign profile. But generally, that's a first stage approach.
Morgan asks, if they have multiple swabs from different locations, will they stop testing as soon as they have located foreign DNA, or will they test all swabs?
That's going to depend on the jurisdiction. Generally, if in some of these larger contractual agreements, they'll screen 3 and they'll test 1 most probative sample. If they obtain a foreign DNA profile, then they stop. In some places, they're going to test all samples no matter what. As in some places, there could be different charges depending on where the DNA is found, whether it's found internal vaginal, internal anal, from the body. So that's just kind of how the procedure is going to start.
Jane says, I guess my concern is the difference between the lab person's belief as to what is the most probative and law enforcement's belief as to what is the most probative.
So I would say in my experience of working in the crime lab, in day-to-day modern testing, yes, a law enforcement's influence on what they need to test in order to help with their investigation is important. In dealing with these thousands and thousands of kits across the country, it's not that there is not importance on what the law enforcement believes is true or believes it occurred. It's just a way to help initially screen these cases that have never been submitted, that have never been collected, to help try to obtain data as a first wave. And then, I don't really see the end to this right away. There's going to be additional studies that can be done afterwards, additional ways to look at the cases. I think a lot of research needs to be done on these kit initiatives in order to come out with the best policies and procedures. So it's just commonly what's occurring right now. Doesn't necessarily mean it is the best way, but it's a practice that's being used to help screen these cases. If a lab personnel, sometimes when a case is completed at a certain stage, let's say the lab tests what they think is most probative, and then that report gets issued to the investigator, it's not uncommon at that point during the investigation for the law enforcement or the prosecuting attorney to say, hey, I need more samples tested in order to really get this to a point where we can prosecute or in our investigation. And so you'll have to have those conversations with your laboratory to process additional samples that might be probative later.
Thank you for that, Amy. We'll give it a few more minutes if folks have any additional questions. If you think of questions after this webinar, please feel free to reach out to the SACI email address, which we'll see on the last slide today. And then if you have a SACI site liaison, feel free to reach out to them or post on the SACI discussion forum. It doesn't look like we have anybody else typing questions at this time. We'll we'll go ahead and move on to our poll questions. Everybody will take a few moments to fill out these questions. We greatly appreciate your feedback on today's webinar. This definitely helps us as we plan our future webinar sessions. Looks like we still have some votes coming in, so I'll give it another minute or two. Thank you, everybody, for participating in these polls. We can go ahead and move to our closing slide, and I will ask Amy if she has any last words she'd like to give you all before we close out this webinar today.
Just say thank you for your time and attention. And if you have questions and even some of the discussions that were being brought up in the chat today, they're really important discussions even beyond this webinar to have with your jurisdiction and to even share policies nationwide on how to determine what's probative and what should be tested and where you want to go moving forward. So I encourage you to use the SACI discussion board so we can talk further on these. Or request any additional training that could be needed to help form better policies.
Great. Thank you so much, Amy, for presenting today's webinar. I want to thank all of our participants as well. On this last slide, you'll see a link to a survey. You can take a few moments to take this survey. It provides us with feedback on today's event. You'll also see our SACI contact information, our help desk line, our hotline, and our website as well. You'll also find links to our Facebook page, Twitter page, and YouTube, so feel free to check out the information there as well. Thank you all for attending today.